Okay, we're going to talk about matrices. The first thing we'll talk about is the definition of a matrix. A matrix looks like this example, A equals. This top is called a row, -3, 6, 24. The bottom row is 0, -15, -7. The first column is -3, 0. Second column is 6, -15. The last column is 24, -7. When you talk about this, the size of this matrix is a 3 by 2. All right, the definition of a matrix is a rectangular array of numbers and variables in rows or columns usually enclosed in brackets. Okay. First bullet in the next section is talking about elements. Elements are the individual values within a matrix. Element A times Y, or A sub Y. Let's squeeze a little X right there. Let me start that part over. A sub XY is used to denote each element where X is the row and Y is the column number where the element is located. Okay, let's see if we can make some sense of that. We have some directions. It says given matrix A, and if you notice right here it says matrices are named using a capital letter. It says to find the value of each element. So I have this big matrix right here. It is a 5 by 3. That's the size of that matrix, and that's important when you're dealing with matrices. I read this as A sub 25, which means row 2, column 5. So if I look at that, row 2, which is here, column 5 is here, so that would be -2. Number 2 is A sub 31, which means row 3, column 1, which is this number 5. Number 3, A sub 12 means first row, second column, which is 40. A sub 34, third row, fourth column, which is 52. Number 5, A sub 15, first row, column 5, which is 21. And A sub 22 means second row, second column, which is 32. All right, dimensions. We've already talked a little bit about that, but the dimensions of a matrix with M rows and N columns is said to be an M times N matrix. All right, number 7 says state the dimensions. There's 1 row, 3 columns, so this is a 1 by 3. Number 8, there's 4 rows, 2 columns, so this is a 4 by 2. Number 9, there's 3 rows, 1, 2, 4 columns, so this is a 3 by 4. And number 10, there's 2 rows, and 1, 2, 3, 4, 5, 6 columns, so that is a 2 by 6. All right, equal matrices. The definition is 2 matrices in which each element in one matrix is equal to the corresponding element in the other matrix. All right, there's some special kind of matrices. The first one's called a row matrix. That means there's just one row. There can be any number of columns. A column matrix means there's just one column. There can be any number of rows. A square matrix just means that you have the same number of rows and columns, like this would be a 2 by 2. And a zero matrix is any size matrix that is all zeros. Okay, we can add and subtract matrices. It says they can be added or subtracted if and only if they have the same dimensions. Simplify, add, and or subtract corresponding elements. So number 11 says to add matrix X plus matrix Y. So that means I would take these two matrices. I would add corresponding entries. So like I would add 24 and negative 15, which would be 9. I'd add negative 8 plus 29, which is 21. I would add negative 3 and 17, which is 14. Negative 4 and 9 is 5. 6 and negative 5 is 1. Negative 17, negative 2 is negative 19. Number 12, I would take matrix Z and subtract matrix W from that. The order matters. If I was on notebook paper, I would actually physically write those down. I write this one first, this one last. So I would take this first entry, negative 3, minus negative 1, which is 2, or negative 2. I would take negative 2 minus 9, which is negative 11. I'd go to the second row, negative 16 minus negative 11 is negative 5. 0 minus 15 is negative 15. Last row, 12 minus 8 is 4. And then 9 minus negative 20 is 29. 13 says to add W plus X. If you look at this, the matrix W is a 3 by 2. Matrix X is a 2 by 3. Those are not the same dimensions, therefore you cannot add those, so that is not possible. 14, I'll take X minus Y. I can subtract those. I subtract entries that are in the same place. My answer is 39 on the first row, negative 37, negative 20. Bottom row, negative 13, 11, negative 15. All right, the last thing we'll talk about is called scalar multiplication. Matrices can be multiplied by a constant called a scalar. In this process called scalar multiplication, each element in the matrix is multiplied by the scalar to produce the new matrix. So number 15, I'm going to take matrix X and multiply every entry in that matrix by 3. Okay, so it's kind of like distributive property. I'll take and multiply everything in that matrix by 3 3 times 24 is 72. 3 times negative 8 is negative 24. 3 times negative 3 is negative 9. 3 times negative 4 is negative 12. 3 times 6 is 18. And 3 times negative 17 is negative 51. Notice the size doesn't change, it has the same dimensions. 16. I would take matrix W, distribute 3/4 to that. 3/4 is called the scalar, so that's negative 3/4, 27/4. Second row is negative 33/4, 45/4. And the last row is 6 and negative 15. Number 17, I'm going to have to take matrix X, distribute negative 5. When I do that, I will have negative 120, 40, and 15. Bottom row is 20, negative 30, and 85. Okay, then I'm going to take matrix Y, distribute 2, which would be negative 30, 50, 34. And to the second row, 18, negative 10, negative 4. They are the same dimension, so therefore I can add. I'll add corresponding entries like negative 120 and negative 30 is negative 150. 90, 49. The bottom row is 38, negative 40, and 81. Number 18, I would take.
I need Miss Livingston, Mr. Thomas, and Miss Wagner to report to the English lab with your Power School login, please.
Number 18, I would take matrix W and distribute 4. When I do that, I would have negative 4, 36, negative 44, 60, 32, negative 80. And I'm going to subtract matrix C from that. The dimensions are the same, so I can subtract corresponding entries, and my answer is negative 138, negative 28, 60, and 20, negative 89. Okay, so that's my final answer. Number 19, the first step for this kind of problem, I see parentheses. So I have to take matrix W, add it to matrix Z. When I do that, I would have negative 4, 7, negative 27, 15, 20, negative 11. I'm going to take each entry, multiply by negative 3. That's called my scalar. So after I distribute negative 3 to everything, that's 12, negative 21. 81, negative 45, negative 60, and 33. Okay, the last problem that is in our notes, number 20. I need to take W and subtract subtract X. Then I'm going to take the 1/2, that's called my scalar, and I'm going to distribute that negative 1/2. So when I subtract Y minus X, the top row is negative 39, 37, and 20. The bottom row is 13, negative 11, 15. And then when I distribute the 1/2, that's negative 39 over 2, 37 over 2, 10. And the bottom row is 13 over 2, negative 11 over 2, and 15 over 2. All right, that's what